Okay, let's take a look at the second video for 7.3, multiplying and dividing binomial radical expressions. Now, don't freak out. It's not as complicated as it sounds. Let's take a look at a couple of examples. All right, so let's refresh our memory on what a binomial radical expression is. Well, a binomial just means two terms, remember? So we have two terms, and we're multiplying it by another binomial. So for this, we're just going to do foiling. The only difference from what we've seen before is that we have a radical here. So let's do FOIL. So we're going to multiply 2 plus 4 times the square root of 3 times 1 minus 5 square root of 3. So we do the first terms, 2 times 2, and we get 2. We do the outside terms, 2 times negative 5 square root of 3, and that's just going to be minus 10 square root of 3. Then the inside terms, 4 square root of 3 times 1 is just a positive 4 square root of 3. And then finally, the last terms, positive 4 square root of 3 times negative 5 square root of 3. This is where you need to pay a little bit of attention. So a positive 4 times a negative 5 is negative 20. And then we have the square root of 3 squared. Well, what happens when we square a square root? Just like when we took the square root of a square, these things will cancel out, and this just becomes a 3. So for this last term, we have minus 20 times 3. If we combine these terms, so these are like terms, we just realized that we can add those together. They have the same index and the same radicand. So negative 10 square root of 3 plus 4 square root of 3 is going to be a minus 6 square root of 3. And we still have this 2 on the front. All right, we can simplify further because negative 20 times 3 is negative 60. 2 minus 60, we can combine those terms. Those are both constants. So 2 minus 60 is negative 58. And minus 6 square root of 3. And that's our final answer because those are not like terms. We can't combine them. So we multiplied two binomials and we ended up with a binomial. All right, we have a special case of binomials. These are both binomial radical expressions. There are radicals in here. They both have two terms. But if we look at them, look at both their first terms are the same. Their second two terms are the same. The only difference is that one has a plus and one has a minus. So we call this pair conjugates. So when we multiply conjugates together, something interesting happens. What happens is that middle term, what we had up here with this middle term, this negative 6 square root of 3, that falls out. That all of a sudden becomes 0. So let's take a look at what that looks like. We're just going to multiply a binomial the way we usually would. So foiling, first terms, 3 times 3 is 9. The outside terms, 3 times negative square root of 7 is negative 3 square root of 7. We never mix up the numbers on the outside of the radical and the numbers on the inside. The inside terms, the square root of 7 times 3 is a positive 3 square root of 7. And finally, the last terms. Positive times negative is going to make this negative. And then we have a square root of 7 squared. So let's take a look at what happened. Well, first of all, a negative 3 square root of 7 plus 3 square root of 7, well, those cancel each other out. Those are 0 when we add them together. So we have a 9. And then, look at this. We have minus 7, the square root of 7, if we square it, we just get 7. And now we have two terms that we can combine. So 9 minus 7 is just 2. So if we know that we have conjugates, they have the same terms, the first terms and the last terms, but they have the opposite signs, we know that what we can do is just square the first term, so 3 squared, and subtract the last term squared. So the square root of 7 squared. 3 squared is 9 minus the square root of 7 squared is just 7. So we end up with 2. And we can do that all the time. Let's take a look at when we might use that. Well, remember when we're rationalizing the denominator, we need to get rid of this radical. Well, we just learned that if we multiply by the conjugate, so the same first and last terms but with an opposite sign, the middle terms will go away and we'll just end up with a constant. So let's do that here. We're going to multiply this, both the numerator and the denominator, by the conjugate of this. So we have the first term and the last term the same, but instead of a plus, we're going to put a minus. If we multiply the denominator by that, we have to do the same thing to the numerator. So let's multiply these out. Let's do the denominator first because it's kind of interesting. Just realized that when we have conjugates, the same first and last terms, but different, same first and last terms, but different, same first and last terms, but different signs in the middle, then what we can do is we square 4. So we get 4 squared minus the square root of 3 squared. And then on the top, we're going to FOIL. 2 times 4 gives us 8. Times negative square root of 3 is negative 2 square root of 3. Negative square root of 3 times 4 is negative 4 square root of 3. If I'm going too fast, you can always pause it. And negative square root of 3 times negative square root of 3 is negative square root of 3 squared. So we did all of the multiplying. Now we just need to simplify. So in the denominator, 4 squared is 16. The square root of 3 squared is just going to be 3. And in the numerator, these two middle terms combine. Negative 2 square root of 3 minus 4 square root of 3, negative 6 square root of 3. And then if I square the square root of 3, I just get 3, so minus 3. Now let's combine any like terms. In the numerator, 8 minus 3 is 5, and the negative 6 square root of 3 is left all by itself. In the denominator, 16 minus 3 is 13. So we have rationalized the denominator. If you tried to put this in your calculator, you would get the same thing as if you put this in. The only difference is that we got rid of the radicals in the denominator. So that's a use for multiplying conjugates. So I want you to take a look at these two quick checks and try them on your own. Have a great day.